question. Is this talk supposed to be given in English or in Polish? In English. Is there anyone who needs this lecture to be given in English? Then we stick to, okay, there are people who need this to be given in English. Sorry, I simply forgotten and I didn't check the agenda. Okay, I think we start now, right, because it's getting quite late. Welcome to the talk with this lengthy title. Right, so what this talk is about. I don't know if you're like me, but maybe if you try to follow something on social media or like regular media, even newspapers, if you get get a proper head card or everything, everyone speaks about AI, right? Everyone is speaking about AI. So sometimes it reaches the level when you're even afraid to open your fridge because AI might be somewhere between the carrots and the yogurts, right? So you have this nasty feeling called FUD, which can be translated as fear, uncertainty, and doubt. Basically, you have this feeling everyone around you knows way more, right? And you don't know what to do now. You're afraid of the situation, everything. So this talk is going to do the thing like we know from The Office, right? The series The Office. Here, Creed is trying to decipher the acronym BOBODY, right? So BOBODY. Who knows what B stands for? Business. Right? So this is this talk. We'll be deciphering these acronyms. Chances are, if you already are doing something with AI, you might find this talk somewhat boring, right? If you haven't done anything with AI and you'd like to decipher these BOBODY with me, you're in the right room. Cool. So briefly about myself, I'm Piotr Przybył. I work as developer advocate for a company called Elastic. I'm also Java champion, test containers champion. You can find me on social media here, there, like LinkedIn and other places as well. Who are you? Who's a developer? Okay, who's Java developer? Who has Java 23 in production? Okay, like a few hands. Okay, just a few hands. Okay, if you're not the developer, who are you? Shout. People are like, this is not very helpful. Okay, little warning. First, when I'm stressed, I tend to sleep words, right? Especially if the disparate profile is somewhat odd, right, and gives you this yellowish vibe. That's one thing. The other thing, it's early in the morning. The coffee didn't kick in. Last but not least, the landscape of AI changes rapidly, right? So it might be that after I give this talk, you will see an announcement basically falsifying half of the talk I have given you. So keep that in mind. The whole landscape changed a lot. I used to study AI at university, fun fact, like well over like 10 years ago, right? And I have like in an addendum to my diploma, I have, yes, AI path completed, right, with great success. But things have evolved, right? So I had to catch up as well. Who knows what FOMO stands for? Yes. Fear of missing out. Very nice. You got jealous. But let's try to do this the proper way a developer would do that, right? So let's go to IntelliJ, right? It works now. Yay. And what I can do here is like I'm going to connect to the OpenAI's chat model. I mean the SaaS one running in the cloud, right? I'm going to provide my API key, although demo could also work in certain scenarios. I'm choosing to be using GPT 4.0. I set here the timeout and I build it. The temperature, I mean, there is this term, you set a temperature from 0 to 1. 0 means very conservative, and you want to use it if you're doing, for example, legal advices. You want the AI agent not to hallucinate or hallucinate as little as possible. Or, for example, you want to be creative, full YOLO mode, then you switch to 1.0, okay? This is the temperature. And this is my prompt. Tell me in one sentence what FOMO means, right? And we're going to see the response and everything. So fingers crossed that demo gods are with us. And the answer is, yes, refers to anxiety or regret one feels when they believe they are missing out on an exciting or interesting event or opportunity that others are experiencing. So chances are you have this FOMO feeling, right? Yes, so as you can see, it's not difficult to start using AI in your stuff. Basically, it's just yet another service you have to call, and that's it. And you can use it to generate stuff and so on and so on. But before we do that, let me go quickly through how we ended up being there. So, an algorithm. If you know precisely how to do something from point A to point Z, right? There's just a number of sets, I don't know, for a new medicine or how to cook a great meal, you just follow an algorithm. And given the same input criteria or the same input ingredients, right, you will end up with the same output if you follow the algorithm, right? This is what we used to do for decades as developers. But there's this other thing. Sometimes you know what you have at the input, or you know your start conditions, and you know when you will be satisfied in terms like, I like this result or not, basically, right? But you don't know how to get there. So normally, as human beings, we use a thing called intelligence, and it's maybe not even a thing, right? It's a kind of like concept. We are somewhat intelligent creatures, right? And then we can do stuff even if we haven't seen anything before. Even if we don't know how to do something exactly, we know how to do stuff because we are intelligent. And we can translate the same principle or way of solving things to computers, basically. So we can have programs behaving this way, so they given like start criteria, we can assess or judge or rate the output they generated, right? And the thing can learn or become intelligent in between, right? So this is general term AI. And now, sorry, I have to do a little detour, like 30 seconds in Polish, because we are in the capital of Poland, so I think it's very fair. Trochę mi się nie podoba, jak wszyscy co chwilę mówimy AI. Nawet ustawę się wpisze w Warszawie, coś tam AI. Jak jadę na konferencję do Niemiec, to Niemcy mają KI, Künstliche Intelligenz. Jak jadę do Francji, to Francuzi mają IA, Intelligence Artificielle. A jak jestem w Polsce, to musi nam koniecznie wychodzić słoma z butów i jakieś zacofanie i nie możemy powiedzieć SI, bo sztuczna inteligencja, tylko musimy mówić AI. I szczerze mówiąc nie rozumiem dlaczego, więc bardzo was proszę, jeżeli mówicie po polsku, nie wiem, do swojej babci, koleżanki, syna czy kogokolwiek, mówcie raczej SI, a nie AI, ok? Można mieć trochę godności człowieka. Okay. Thank you. That would be it. If you don't speak Polish, don't worry, you didn't miss anything. It was related, like the only rant on Polish as a language, a society. Anyway, so this translates as artificial intelligence. So then we go further. And artificial intelligence means a whole variety, the whole plethora of different approaches, kinds of algorithms, solutions and everything. And one of them is neural networks. And basically it mimics or tries to mimic how neural network, right, inside our brain or our body works. I'm not Sławek Sobutka, so I'm not able to tell you exactly how they're interconnected, but the general principle is this. We have input neurons, they can be connected, for example, to pixels or like to some sensors, right? And we have output neurons. For example, we might have a neural network which will be given a picture, right? And then at the output layer, it will light us like 3 neurons. It's a dog, it's a cat, I don't know. And then you have any number of neurons in between. This thing is called topology, right? And it can recognize, or like because of these connections, like amplifying signals or making signals like less important, it can eventually, based on this input, it can generate this output, right? So this is like a network used for example, image recognition, but we might have any other network, like for, I don't know, other stuff, basically, like lots of stuff, right? These neurons are basically functions, like mathematical functions, right? And this is like, we use like various factors, amplify here, make a little less signal here, and so on. So this is how they work. Pretty much like shown in this AI-generated images. I hope you like these images. I paid $20 so we can see them. Yes, then we go to LLMs. LLMs are large language models. These are basically neural networks trained on tremendous amount of data. Think library, think the whole internet, including Reddit, right, and stuff. Extra points, and this translates as large language model, and extra points go for these things. It can serve various purposes, right? So it can do not only like text generation, but it can try to understand sentiment, identify like people, and generate text and everything. What's important here is this. It has to process natural language, hence natural language processing, right? You type English, you type Polish, and you end up with the thing understanding what you mean. And then it can be, when it's learning, it can be semi-supervised. right? So there was a human being involved, but the thing was somehow like learning or assessing its knowledge on its own. Sorry, I should have taken this badge off. Sorry, that looks creepy. Anyway, and then we go to GPT. GPT is a thing like an LLM, kind of with extensions on extra stuff, created by OpenAI, the company, and it stands for Generative Pre-trained Transformer. Maybe let's like the pre-trained is somewhat obvious, right? It had to be trained before. Transformer comes from a paper that we saw a few years ago, and basically it's like LLM on steroids, you can say. There's a thing called transformer, right? And it can understand not just word after word after word, but it can read the whole sentence and kind of like understand the relationships between words, like which word is more important, even if the words are like, for example, at the beginning and end of the sentence, think German, right? They can understand that these are the two most important words in the sentence, and everything else is just like a noise or filler words or everything. And generative, because it can generate stuff which it didn't even see before. And then we go to GenAI, which is generative AI, and it can generate for us literally like many things. I can't say everything, but many things, right? Not just like programs for our code, so we can copy and paste not only from Stack Overflow, but images, sound, videos. I guess, I mean, right now we expect the folks in the US to elect new president, so you've seen, I guess, like a number of fakes with either candidate and everything, right? So this is this generative artificial intelligence that can generate stuff, and it's not only GPT, it can be many other things, right? So this is kind of like a superset above them all that we discussed so far. And then we come to AGI, which is Artificial General Intelligence, okay? And here is the ongoing debate, and I can tell you the debate is going on. I can't tell you how you should approach this debate, okay? Some people say we will never reach AGI. Some people say we already start having something like this because the GPT 4.0 can be the first step, right? The first super naive AGI. Some people say we'll be done in 10 years. Some people say 2 to 3 years. I don't know, okay? I'm too stupid to assess this. I just want you to know there is this thing. And what it basically means, it's like kind of like human intelligence, so you won't know. So if you give it like, I don't know, some notes or something, it will be able to like give you or generate a recipe for a new cake. What? It's not my screen. Come on. It was too bright, right? Okay, and then, yes, the color profile, I know. It's disturbing me as well. Sorry for this thing to be so yellowish. We didn't figure it out before. Anyway, so it has to be as intelligent, basically, as human being, and fun fact, able to approach any task, because so far these AI things are sort of like designed to solve certain kinds of tasks, like generate images, right, or generate song. AGI would be able to do everything and more, okay? So here we go to this problem, training versus actual use case, right? You've been trained to do something, and these are like very nice training criteria, but then happens. You know what happens, okay? And the question is, how do we tackle this? Because we want to use, as developers, we want to have like our own share of this cake in our products, in our projects and everything. So what's in there for me as mere developer? And I'm not going to tell you about like AI-aided IDEs and stuff. I mean, these are also quite popular. You can find like many talks on YouTube or stuff. But do you know this thing? So in recent Java, there is a thing called stream gatherers. This slide. So basically, instead of having just map and filter, we'll be able to have gatherers like an intermediate operation, right? And I asked ChatGPT, hey, what are these stream gatherers in Java? And it told me, yeah, sure, I can give you an answer, blah, 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 blah. And then you see stream collect and collectors. Because semantically, to collect and to gather, it's really, really close to each other, right? So obviously, we don't want such stupid AI, right? I have another talk about just stream gatherers, if you fancy. Should be already on YouTube. But anyway, here we're focusing on AI. How do I make this thing not to hallucinate, okay? So there's this thing, this concept, this architecture or pattern called RAG. It extends to Retrieval Augmented Generation. And do you recognize this? ThoughtWorks, Technology Radar. So basically, ThoughtWorks releases every half a year this Technology Radar, which means there are like various like tools and so on, and you should either adapt or try them or assess or hold. Like maybe it's not worth to using them, right? And this is the one from April 2024, right? And you can see this number 1 here, and this number 1 here is retrieval augmented generation. It's a technique. It's number 1 technique that moved in, right, that you should perhaps adopt in your systems. So I'm going to focus on this thing. Here's the doc for you. How it looks is more or less like this. I know the architects love this slide because it not only it has boxes and arrows, but these arrows are animated. I mean, like a Zen face, right? Anyway, how did it normally work, right? So even with the general AI, you have your question, right? Here you have your question, and then you take your question, you ask it to this GenAI, and it gives you the answer. But it might not be the right answer if, for example, you want to ask, hey, like, what's my company's policy about this or that? Because fun fact, this GenAI thingy wasn't trained on your private business data. And now you have 2 options. You can spend tremendous amount of money to train, for example, have your own Olama or ChatGPT trained on your own data, right? And you'll have to wait like 6 months or something like this. The idea with RAG is different. You have your own business data, and this thing is intelligent, right? So you search through your business data, or like, I don't know, your song library, your picture library, your inventory, something like this. You select whatever makes sense. You add it to your question as so-called context window, and then with this, like, think about book. Let's say you have the whole book, right, or the whole catalog of your of the items in your e-commerce. So instead of giving the whole book, because that would take time to read and that would be costly to read, you just reap 3 parts because someone was looking for sandals. So you just reap 3 or 5 pages which have anything to do with sandals, or maybe not anything to do, which are the best suited for sandals, right? And you just hand the AI these 5 pages, because AI is intelligent enough to just quickly read these 5 pages and then give you an answer here, right? So this is the idea behind retrieval augmented generation. Now, about this context window, context is a king. I also gave a talk about context. If I say football, it really matters where I am, right? Here, it matters this thing. In the US, it means this thing, right? So the context is a king. You need to select proper context. Now the whole idea is to properly select these 5 pages you want to send to the Dern AI. Right, and you can say, yeah, I can do it easily already with my SQL stuff, right? Let's say someone was looking for like milk chocolate, or like I detected in this input form there were 2 fields, right, milk and chocolate, so I can do something like this. You recognize this? Every Java developer recognizes this, right? The thing is, this works if people were looking for milk chocolate and also chocolate milk, which are 2 different products. So how do you select the right context using this? Okay, not so easy. Therefore, we go into the realm of vector search and this whole vectors, right? So, which is the key ingredient, I would say, of this RAG thing. I mean, you don't have to use only vector search. If you have any other search technique, it would work. But this thing might be the easiest to use. So let's go quickly through the vectors. This is the simple one-dimensional vector, right? And we can assign just something in this spectrum from -1 to 1. Leah is realistic because we saw her in the movie, so this must be true. She must exist, right? And we saw Darth Vader in this cartoonish version, so he is a cartoon, right? Simple, -1, 1. We can add more dimensions. So for the dimensions we can have like someone being human or being machine. So this is a realistic machine droid, right? And she's realistic human, and Darth Vader is like just in the middle between being human and machine, because you know why. Okay, and then as you can see, similar data is grouped together in just these 2 oversimplified 2-dimensional vector space, right? Sorry, I'm Star Trek guy. Who's this character? Look, okay, so this is look. Sorry, I have like a great, I brought it from the US. I have a great dad joke about, related to Star Trek universe. Question, and I have jellies for you. How many ears did Captain Kirk have? 3. Left ear, right ear, and the final front ear. End of joke. Yes, it's so bad. Anyway. What's important in these vector models is this. Once you have your model and you have like a set of coordinates, right, or representation of the vector, like we have this little triangle here, it matters that it is related only to this coordinates, this model, the way we see it, right? As you can see, this triangle looks like this. If we just take and translate this triangle to a different model, seemingly similar, but not the same, it can be basically rubbish, right? And in French, they say bullshit, right? So you have to be, if you get this vector, you need to understand 2 things: the vector and the model that was generated, that was used to generate this vector, right? Do you recognize this scene, more or less? Rings a bell? Yes, it's a yes, very nice. It's a Matrix movie. I throw jellies, you catch. Sorry, I throw exceptions way better. Yes. You recognize this scene, right? So this is let's say this is the reality, and this is the vector representation, okay? And matrix is the model, okay? So now you're with me, in this search, world or realm of vector search. Now, Elasticsearch, fun fact, is a nice thing if you need to search for anything. Also supports a vector search, but how it does it, it's like stands on the shoulders of the giant called Lucene. Right, so you can keep vectors in Lucene and therefore in Elasticsearch and so on, different kinds of vectors, dense vectors, sparse vectors, and so on. However, the thing is, how do we make these vectors happen? Right, and there are ways. I will be showing you the Elasticsearch way, even with like commercial vibe, but there are like many things. Basically, when you ingest your data, when you index your data, apart from having like, let's say you have to import the data into your e-commerce catalog, right? So apart from just images, descriptions, and titles, right, you also have to import the vector embeddings or like the vector representation for example, the image or the description or the title. Okay, you have to make them happen with the data somehow, and there are ways, there are techniques. You can ask like a SaaS product, like something cloud provided. You can run it like Olama, like I'm running here on my machine, and ask it this way, right? Or you can have it in your Elasticsearch cloud, cloud or cluster, right? Something like this. So basically, normally we have this. You see ID, product name, description, blah 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 blah. Once we like index this data, but we can also, for example, in the Elasticsearch, we can have inference pipeline, and here we can say, hey, once this is happening, automatically generate for me this description embedding, right? So this vector representation of the description. So this is how the vector search works, basically. So I have my input data, right? Images, documents, audio, whatever. I have vector representations from them, and then when I have the query, I have to generate vector representation using the same model, so I find the nearest neighbor or nearest neighbors, and I have results. And fun fact, in many cases, you don't need to go for like a RAG solution. Vector search alone might be enough, right? So just don't go like instantly, oh, I need RAG. Maybe you just need vector search, and that's it, right? Yes, and how it works, once you import a model, for example, I mean, there are many ways. Somehow you need to tell the darn thing what is the vector you'll be comparing it against, right? So one way is, for example, to have this model running in your cluster, right? And you just say this is the model and this is the text, or you can generate the representation like first call like a service. It will generate you the vector representation, and then use this vector representation to ask your search engine, right? Something like this. There are many, tremendously many of these models. This is a picture from like 2 years ago, and the tree, of course, is like growing. There's more of them. There are open ones, closed ones, and so on. But you need to know, you want to know where these models are living, where they're coming from, right? Do you know Maven Central? Yes, of course. So there's a thing called Hugging Face. If you want to get AI models, like the free ones and so on, you go to Hugging Face. This is like repository for AI models, right? And there are many things, and they can do a number of things. Like I can show you a few things they can do in here. Right, so I imported some models into my Elastic cluster because for me it's a convenient way of running this. You can import them, I don't know, you can even run them in test containers or Docker or whatever, as long as you have like a decent GPU support, of course, right? So as you can see, I have different models imported, right, in my cluster. And now what I can say, for example, is this is my text field, my query. See, my name is Piotr and I live in Wrocław, Poland. And I'm going to run it through this model, and it can tell me Piotr is a person and Wrocław is a location and Poland is a location. Very useful, for example, if you need to get rid of personal data from your logs. Or if you run, for example, a chain of restaurants and somebody complains, you need to know which restaurant they complain about, right? Something like this. So it's not only about generating funny memes, okay? Let's say someone had to wait half an hour for French fries and AI can tell you it's a negative comment. So if you have negative comments, you want to address them before the positive ones, right? So perhaps they're still at the place and you can, I don't know, offer this something, they remove it and stuff, right? It can even assess and tell you what kind of feeling that was, that they were actually angry, right? Now what they can do, there are more examples they can do, right? But these were just a few. Sorry, and now I've lost this. Yes, that's inconvenient. Anyway. So you can import these models from Hugging Face, like either to Elasticsearch or like to your own solution, whatever, right? And then vector search is about numbers. So you can think that these are basically like a big array of numbers. This can be like bytes or integers. This can be like floating numbers, right? Anything. Semantic search, it's like the numbers mean actually something because the model that generated these vectors, these embeddings, actually gave them meaning, right? Together, it means that these numbers have meaning. You see the numbers, right? And you see the lady in the red dress, basically. And they're not just literal match. And to show you this, to demonstrate this, wrong window again, this one, yes. So, how to generate these, I have this quick, this simple sentence about, the quick Fox. And as you can see, this is the vector representation from this very model of this sentence, right? And now I have 3 sentences which are the same at the beginning. There's just lazy dog, lazy wolf, and lazy programmer, right? And now if I generate embeddings for all three of these, as you can see, this is like 0.03 minus 0.29 and so on. So this is the representation of this sentence. And here, the second is this thing. So it has different numbers in the beginning. So the vector doesn't mean that the difference, just because you could assume, okay, I have difference at the end of the sentence, so there will be only like a different numbers at the end of this vector. No, this is not how it's working. The whole thing has its meaning, and it's carefully placed in this like a multi-dimensional space for these vectors, right? This is important. So we can't think of them like naively or like, I don't know, we can't multiply these numbers by 2 or something like this. It doesn't work like that. Sorry. And now let me go here again. Yes. So now I have to look for Han Solo, right? And this is my query, and these are my results, ordered by like most significant or like best match and the worst match from what I have. Why? Because Han Solo is realistic human, right? So here, he'd be just as Princess Leia, because Luke is not entirely human, right? There's something wrong with his palm, right? And so on and so on. So here we can see what's the order of, what's the similarity between my query, right? Which I would need to translate into this matrix, right? Or this model, should I say, and then get the results. So we get back to this RAG. So this is how we can search for this context window, right, combined with my question. And this question should be the query to find this data, right? Together, combined, we send it to the GenAI, and we get nice results. The thing is, sometimes it is not enough. Why is it not enough? Let's say you want to search for orange. And what does, like you run an e-store and someone typed orange. What can orange mean? It can mean company, it can mean fruit, right? It can mean just things that are orange. I don't know, orange sandals, and they didn't just go for sandals. It can mean maybe something related to the Netherlands, because Oranje and stuff, right? So sometimes turns out that good old-fashioned query is still better than the vector search. Okay, and now what we have here is hybrid search, because we'll be searching using two approaches at the same time. So this is a good old-fashioned semantic query, right? And this is this, let's say, new fancy thingy vector search, okay? And as you can see, I can filter. So this is like a department for women clothing, right? And here I have this query representation. See, I called like a service. It gave me the vector representation, right? And of summer clothes. So this model, like I made a call. It translated summer clothes into this vector embedding, right? And now I'll be asking my, let's say, Elasticsearch using like two mechanisms at the same time. So that's why it's called hybrid search. The thing is, when you run this on your machine, you find out that the best results are given when you tune the boost factors, right? So here you boost it by 90% and here by 10%, right? And then you get the perfect spot for summer clothes. But you don't know what people are going to use in production. And you can't have like a human operator to tune the boost factors for every query that comes in, right? So maybe what we need, apart from this hybrid search, we need hybrid scoring as well. So what it basically does is gives us a score that is not, you know, if you work in anything with Elastic search, you know that there's a, if you have like a search result, you have a score, right? So each result is scored. But now we can combine them, so we have like a proper list of properly ordered stuff, right? And we go for this, reciprocal rank fusion. It's like this pirate slang, ruff, ruff. Anyway, do you know the concept of racing, Formula 1 racing, or ski jumping? Nobody watches ski jumping here? Okay, exactly. Who ended up first? Sorry, who was that? Was that you? Yes, get jealous. Exactly. Thank you very much for helping me. It matters if you are first or second or third in a race, and so on. And then we don't like summarize the times that you got from different tracks, because fun fact, every track is different. So this in this track, this result means something, this lap time, for example, and the other track, it means something else. So what we do instead, we say, okay, you were first in this race, second in this race, and fifth in this race. So globally, after the whole season, you will be position 2. Right? So this is the idea behind this hybrid scoring. RRF is a very nice implementation of it, because the paper has just 2 pages. So instead of having these boosts, what you can have this RRF, for example, and then it will figure out like which position was here, which position was here, and it will combine the results, right? So this puts you safe, so you don't have to like cut the old search off, sort of, and just switch to vector search. You can migrate your stuff, so it will be still using classic search, sort of, but already benefiting from vector search, right? So this is one of the ways you can go for that. And let me show you a quick demo, because in code we trust. So I have a soupy dummy rag. Don't do rags like this, okay? This is just for demo purposes, but I hope it will do. Okay. So what we have here, this is the key part, right? I have my AI assistant. Again, I'll be using a chat language model and content retriever. This is for this context window, right? So how to grab the 5 pages. And what I'm doing here, I want to find out what is this bloody stream gatherer in Java. Okay, so what I did was this. Let me go quickly, maybe here. I have imported into my Elasticsearch Do you know the concept of JEPs, Java Enhancement Proposals? These are like RFCs only for Java, kind of like, right? So any big or decently big feature gets its own JEP, right? And it's available on the internet. So you can go like to the web, index them all and grab them, import them into your database or document store or whatever. So this is what I did, right? And what I also did is like then I said, hey, I also want you to generate vector representations of these, right? And you can see these vectors are 3, 8, 4 in size. All right, so I also have vector representation here, which means if I'm going to search here using this RRF stuff, right, and I'm going to use a typical query and also like tell me what a stream gatherer is, using this model, I should get some results. And the results are here, right? So you can see the top result is this JEP 461. And then there is 473 and so on and so on. So I expect this thing to find for me, when I ask this question, using this content retriever to find for me these documents, okay? I basically connect to my Elasticsearch, nothing super, sorry, wrong thing. This content retriever comes from here. As you can see, I even put it in name, it's dummy, right? But what it does, basically, I have the search request with the k nearest neighbors, right? So I find 3 using this model, blah, 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 blah. Anyway, it gives me basically a list of content, right? And this is the body of the content. I can also get, and this is a nice property, by the way, of the RAG. What it can give me here, as you can see, I selected like additional URLs, and I can also go for URLs. So I know where this knowledge is coming from. I can bake it up with sources, right? So I can go and read it as I mean, the human operator, say you're a lawyer or a doctor or a chef in a restaurant, you can actually go there and verify if the thing isn't hallucinating too much. Anyway, so I selected these, I was selecting these documents, right? And I'll be asking then this ChatGPT-4, because this is my language model, hey, tell me what a stream gatherer is in Java, right? Poorly translated sentence. Anyway, let me try to run it, and let me see if we have a result. It somehow takes time. Why does it take time? It should be running. It's not running any, okay. Did you spoil or run my demo? What's the shortcut to see? Sorry. Why doesn't it show the result? Come on, run. It should show like, okay, I made it this, sorry, stupid me. It's working. As you can see, it's only like I didn't operate the windows properly. Anyway, it is showing the documents it fetched, right? So I can verify this is like a full swing debug mode. Anyway, this is the answer, and here's the answer that came. A string gatherer in Java, where is it? So, oh, come on. See, I'm a very clumsy computer operator. Yeah, a stream gatherer in Java introduced as a feature in JEP, right? So we selected carefully these few pages, sent it to the AI, and it was able to generate the proper answer. And just by assessing this, yeah, it has initializer, integrator, combiner, and finisher, yes. And only integrator is mandatory. The other three things are optional, so it didn't hallucinate. This time, it gave us the proper answer. See, so this is how easily you can generate, implement RAG into your architecture, right? If you need it to be there, right? Because then people are asking me this question, and somehow they feel or think I'm the proper person to answer this question, right? Will the AI take my job? And I can tell you that the whole AI thing is kind of like this sword with 2 edges, right? And you basically need to become like a more sophisticated operator of AI than I am of the IDE, okay? Especially when I'm giving a talk. There was this guy, I don't remember his name, but he said, like, you shouldn't be worried that the AI will take your job, at least in the next few years. I'm just quoting him. He said, you should be worried that the person sitting next to you who knows how to use AI will take your job, okay? So this is it. So maybe you just give up your FOMO and start playing with this just even as a developer, right? Not just using like assistance in your IDE or something. Just try to use it as a system. Maybe enhance something, add something to your product and something like this. But this is what my boss posted on Twitter the other day. And these are his views. These are not the views of the company we're working for, right? But not every single product needs a AI assistant, right? Or AI integration. Just because you have a fridge doesn't mean you have to stick AI between yogurts and carrots, okay? Maybe it doesn't fit there, so just don't push it there, right? And I can like fully agree with this. Luckily, I didn't have to tweet about this, right? Don't push AI everywhere, only where it makes sense, right? Don't make it, please, another blockchain hype. If you need our help us from Elastic people. I brought you some stickers, right? You can go and grab them after the talk. They're here waiting for you. If you need to ask us a question, please go to our forum. This is like where we try to help our community. It's called Discuss Elastic CO. This is where we answer people's questions. Or if you're more like a Slack fan, you can go for our Elastic community Slack space, right? This is also where we answer your questions, right? Then I need your help now. I know there will be like a form asked by the conference and whatnot, but if you'd like to share with me what you liked about this talk or not, I would really appreciate this. It will take you 5 seconds to 1 minute. In the meantime, I'd like to take a selfie with you because, I mean, there are so many lovely people. Okay. Can you say like cheese? You activated it. Very nice. Thank you. Thank you for helping me.